All right, my dear children of class 11 science, we do new topic now, important topic. This is also a formula that we are going to derive, and this is basically a formula for the flow of liquid through pipes. Flow of liquid through pipes, and this is the formula derived by Poiseuille, and is called Poiseuille formula for the flow of liquid through pipes. Okay. Now this formula basically derived for the volume of liquid. The volume of liquid flowing per second. The volume of liquid flowing per second, that means also called the rate of discharge of liquid through pipe. And this volume of liquid, okay, flowing per second or rate of discharge through pipe, okay, can be expressed in terms of the coefficient of viscosity of liquid. It is also expressed in terms of the radius of the pipe, because pipe are basically what in shape? Circular in shape. And the pressure, and the what? Pressure gradient exerted on the liquid. Now pressure gradient, see children, try to understand this part. You know pressure means force per unit area. But for every length of the liquid which flows in a pipe, there is a pressure change exerted by the liquid, which changes per unit length of the liquid. And this change in pressure per unit length is also called pressure gradient. So what is the main objective of this Poiseuille formula? To find the volume of liquid flowing per second, which can be expressed in terms of the coefficient of viscosity of liquid, the radius of the pipe, okay, and the pressure gradient of the liquid. So in this case, in order to derive the formula, okay, Poiseuille performed an experiment, okay, passing the liquid flowing through the pipe. Okay, now it was experimentally observed that the volume of a liquid flowing per second, that is also called the rate of discharge through a pipe, depends on three factors. So one of the first factor in which the volume of liquid flowing per second depends is the viscosity of liquid. The viscosity of the what? Liquid. Every liquid has viscosity. And you know viscosity of liquid is expressed by symbol eta. So eta is the symbol we use for what? Viscosity of liquid. Number one. Number two is the radius of the pipe. The pipe in which the liquid flows has a radius. Okay. And the radius of the pipe. That means the rate of flow of liquid means the volume of liquid flowing per second also depend upon the radius of the what? Pipe. And radius is basically marked by small letter r. And lastly, the volume of flowing liquid flowing per second also depend upon the pressure gradient. Pressure what? Gradient. The pressure gradient means change in pressure per unit length. Pressure gradient means also called change in pressure. Okay, let me write down change in what? Change in pressure. Pressure per unit length. Unit length. So these are the three factors in which the volume of liquid flowing per second depends. But in order to derive the Poiseuille formula, okay, we derive by the method of dimension. So children, out here we use method of dimension to derive Poiseuille formula. So for that, I consider let B be the volume of liquid. Be the volume of liquid that is flowing in a pipe. In how much time? I write down the time is what? T. So in time T, how much volume of liquid is flowing? B. Then I write down Q equals to B by T. Okay, let me mark by letter Q. Q equals to B by T. Now B by T means the rate of flow, rate of volume of liquid. Rate of volume of liquid means the volume of liquid flowing per second. So that means B by Q is the volume of liquid. Okay, it is the volume of liquid flowing per second. So the volume of liquid flowing per second is given by B by T, and that is equals to Q. So as I said, the volume of liquid flowing per second depends upon these three factors. But to derive the expression, we follow the method of what? Dimension. Okay. So I write down by the method of dimension. It can be written as Q. Q is directly proportional to eta. This is eta means the coefficient of viscosity of liquid with the power what? A. Now children, this part you need to understand because you have learned already in the chapter called dimension analysis. Dimension analysis, one main application is it is also used to derive the expression, in order to derive the formula related to different physical quantity. And this Poiseuille formula is also the formula related to this B by T, the rate of volume of liquid flowing per second, in terms of viscosity of liquid, radius of the pipe, and the pressure gradient of the liquid. So one of the first factor in which the rate of volume of liquid flows depend is the viscosity of the liquid. But by the method of dimension, I consider Q is proportional to eta with the power A, where A is the dimension of Q in eta. So let me just give this as equation 1. But as per the observation, Q is also dependent on the radius of the pipe. So I write down experimentally, by the method of dimension, Q is also proportional to R, but with the power B, where B is the dimension of R in Q. Okay, similarly, Q means B by T, which also directly proportional to pressure gradient. Now pressure gradient means pressure per unit length. So which is Q is proportional to, I write down, pressure is P and length is L, then it is P by L, and to the power C. So I give this as equation number 3. So if you look at the expression, children, that this is coefficient of viscosity of liquid, this is radius of the pipe, and this is pressure gradient. This is P by L. So that this rate of flow of volume liquid, okay, is expressed dimensionally by these 3 equations. So what I do, I combine this equation. Now in order to derive the formula, I combine equation 1, 2 and 3, both sides. I write the equation as Q is proportional to eta to the power A, R to the power B, and you can see P by L with power C. See, I have already considered equation 1, 2 and 3. So I combine both sides, means left hand side, right hand side, and your left hand side is Q. That's why combining is also Q. Right hand side is 1, equation 1, right hand side is eta to power A. Right hand side of equation 2 is eta R to the power B, and right hand side of equation 3 is P by L to the power C. Now, as you know, there is a rule, when proportional sign is removed equals to sign, what you have to put? You have to put some constant. I write that constant and say K. So K is a constant of proportionality. So I write down now eta to the power A, R to the power B, and this is B, children, and next is P by L with power C. Now I give this as equation number 4. So I got one of the equation, that is number 4. So in this equation, if you see, K is a constant of proportionality. But we are deriving the expression of this Poiseuille formula by the method of dimension. So what I do, I write now the dimension of equation for both sides. I write the dimension of equation for both sides. Now what I do, put the dimension of each quantity on the left hand side and right hand side. Now quantity on the left hand side is volume per unit time. The unit dimension of volume is what? L cube. Time dimension is what? T. So Q means B by T, but B dimension is L cube, by time dimension is T, so L cube by T equals to. Now when you write the dimension both sides, this is constant, so I neglect this. So I'll not write K, I'll be neglecting K. Okay. Now I write the dimension of coefficient of viscosity. The coefficient of viscosity dimension, see, I've already taught in the last class only, and I write directly the coefficient of viscosity dimension is M L minus 1 T minus 1. Remember this, coefficient of viscosity dimension this much. But there is a power A. Similarly, radius dimension is L only, with power B. Now pressure dimension, yes children, you have learned pressure dimension. Okay, a dimension pressure is what? M L T minus 2. Okay, M L T minus 2? L minus 2? With power C. Now I'll tell you why the dimension this much, because pressure means force by area. This is the dimension of force, MLT minus 2 is the dimension of force. Area dimension is L square, but if I take in the numerator is L2 minus 2. That's why I'm writing dimension pressure is MLT minus 2, T minus L minus 2, but with power C. Now we have denominator term, that is L. The length dimension is L only, but with power C. So children, I have written the dimension of each quantity on both sides. Now let me further simplify. this. So I write down now this as, this power is 1. I'll take in the numerator L cube t minus 1. So if I combine, t to the power 1 become t to minus 1. So if I combine, so L cube t minus 1 equals to, now let me just open the bracket. M power is 1. It will be m. 1 into a means a. L to the power what? Minus 1, or minus 1 into a means minus a. And this is t to the power minus 1 into a means minus a also. Now this power is 1. So let me combine. L to the power 1 into b means b. Now let me take this L in the numerator and do it. Before that, I'll combine this expression. M, L is 1. The 1 minus 2 is L minus 1. It's L minus 1. And this is t minus 2 with power what? C. By L to power C. But L to power C means L to the power C only. So 1, because there is power is 1. So 1 into C means C. That's why this is L to power C. Okay. Now, let me take this in the numerator again. But on the left hand side, there is no m. But still I can write m with power 0. Because there is no dimension of mass in left hand side. So I write on m to power 0. With L to power t minus 1. Now let me combine this. M, A, now L, there are two L's. One is L minus A and L plus B. So, when the bases are same, power will be added. So minus A plus what? B. Then this one, t to the power minus A. So let me take this L to the power C in the numerator. It will be M L minus 2, minus not 2, sorry, this is minus 1. T minus 2 with C into C. L to the power C, if I take in the numerator, it will be L to minus C. Now, on the left hand side, I can further simplify. No, right hand side, sorry, left hand side is already this much. So right hand side, I will further simplify. It will be how much? M A L minus A plus B t to the power minus A. Okay. Now let me combine this. Now m power 1. So 1 into C means m to the power C. L power minus 1 into C is L to minus C. Okay. Into t to the power minus 2. Minus 2 into C means minus 2C. Now there is already minus L to minus C. And that also I put inside. So it will be L minus C. Now I further simplify this expression now, children. It will be M A L minus A plus B t to the power minus A. Now let me combine it. There is M to the power C. This L minus C. If we add, is minus 2C. And this is t to the power minus 2C. Now I can further combine this one. M. Same base, power will be added. So it will be M to the power A plus C. A plus C. L, same base, power will be added. So outer is minus A plus B. And there is minus 2C. This is minus 2C. Then even these bases are same, T. The power will be added. It will be minus A and minus 2C. So finally you can see the expression, children. It will be M0 L3 T minus 1. Now we have done this much. Now children, you know that there is a principle called principle of homogeneity of dimension. The principle of homogeneity dimension says that if the dimension of left hand side and right hand side is same, means the dimension of each term on the left hand side and right hand side must be same. And these are all the dimensions on left hand side and these are all the dimensions on right hand side. So according to principle of homogeneity dimension, these two dimensions are equal. The dimension of mass on both sides is same, which means if I compare A plus C equals to 0, dimension of mass A plus C equals to 0. So I give this equation number 5. Dimension of L on both sides is same, means I write minus A plus B minus 2C equals to 3. I give this equation number what? 6. And lastly, dimension T on both sides is same, which is minus A minus 2C equals to minus 1. And I give this as equation number 7. So children, I have just formed the dimension with the 3 equation. Now in order to derive the formula, I solve this 3 equation and calculate the value of A, B, C. And that I substitute in equation number 4. So with that, we derive the Poiseuille formula. But that continuation part of this topic, I'll do in the next YouTube.